Hello, eighth grade. Welcome to week 11. We're going to be talking about electrons and energy. We'll be finishing up our unit on subatomic particles and atomic theories. We'll be talking about electrons today and atomic theory. The last atomic theory will be tomorrow. The final 3 days, we're going to jump into our unit on energy. So we're going to start right off the bat with our learning target. We should be able to conceptualize the idea of energy levels or electron shells. I don't know about you, but I really like fireworks. And I think that fireworks are a great way to celebrate happy events. But do you know what causes these bright, colorful lights? Well, the lights are bursts of energy given off by atoms in the fireworks. So what causes these bursts of lights? Well, the answer has to do with energy levels of atoms. Energy levels, also called electron shells, are fixed distances from the nucleus of an atom where electrons may be found. Electrons are tiny negatively charged particles in an atom that move around the positive nucleus at the center. Energy levels are like little steps of a staircase. You can stand on one step or another, but not in between the steps. The same goes for electrons. They can occupy one energy level or another, but not the space between energy levels. The model shows the first 4 energy levels of an atom. Electrons in energy level 1, also called energy level K, have the least amount of energy. As you go farther from the nucleus, electrons at higher levels have more energy, and their energy increases by fixed, discrete amounts. Electrons can jump from a lower to the next higher level if they absorb this energy. Conversely, if electrons jump from a higher to a lower energy level, they give off energy in the form of light. This explains fireworks. When the fireworks explode, electrons gain energy and jump to higher energy levels. When they jump back to their original energy levels, they release the energy as light. Different atoms have different arrangements of electrons, so they give off light of different colors. So a quick question. In the atomic model, where would you find electrons that have the most energy? That's right. Electrons with the most energy would be found on level 4. The smallest atoms are hydrogen atoms. They have just one electron orbiting the nucleus. That one electron is in the first energy level. Bigger atoms have more electrons. Electrons are always added to the lowest energy level first, until it has a maximum number of electrons possible. Then electrons are added to the next higher energy level until the level is full, and so on. How many electrons can a given energy level hold? Well, the maximum number of electrons possible for the first 4 energy levels are shown here. For example, energy level 1 can hold a maximum of 2 electrons. And energy level 2 can hold a maximum of 8 electrons. The maximum number depends on the number of orbitals at a given energy level. An orbital is a volume of space within an atom where an electron is most likely to be found. As you see by the images, some orbitals are shaped like spheres, s orbitals, and some are shaped like dumbbells, p orbitals. There are other types of orbitals as well. Regardless of its shape, each orbital can hold a maximum of 2 electrons. Energy level 1 has just 1 orbital, so 2 electrons will fill this energy level. Energy level 2 has 4 orbitals, so it takes 8 electrons to fill this energy level. Question. Energy level 3 can hold a maximum of 18 electrons. How many orbitals does this energy level have? Well, if you do the math, at 2 electrons per orbital, this energy level must have 9 orbitals. Electrons in the outermost energy level of an atom have a special significance. These electrons are called valence electrons, and they determine many of the properties of an atom. An atom is most stable if its outermost energy level contains as many electrons as it can hold. For example, helium has 2 electrons, both in the first energy level. This energy level can hold only 2 electrons, so helium's only energy level is full. This makes helium a very stable element. In other words, its atoms are unlikely to react with other atoms. Consider the elements fluorine and lithium. Fluorine has 7 of 8 possible electrons in its outermost energy level, which is energy level 2. It would be more stable if it had 1 more electron, because this would fill its outermost energy level. Lithium, on the other hand, has just 1 of 8 possible electrons in its outermost level, also energy level 2. It would be more stable if it had 1 less electron, because it would have a full energy level. And that full energy level would now be energy level 1. Both fluorine and lithium are highly reactive elements because of their number of valence electrons. Fluorine will readily gain 1 electron, and lithium will just as readily give up 1 electron to become more stable. In fact, lithium and fluorine will react together as shown here. When the 2 elements react, lithium transfers its 1 extra electron to fluorine. Question: a neon atom has 10 electrons. How many electrons does it have in its outermost energy level? How stable do you think a neon atom is? Take a moment and think about that. Pause the video. And we're back. So, how many are in the outermost energy level? And how many do we think that whether or not neon is stable? Well, the fact of the matter is, because the first energy level has 2 electrons, and the second energy level could have up to 8, 2 plus 8 equals 10. So neon has 10 electrons. 2 are in the first level, 8 in the second level, which can only hold 8. That means the outermost energy level is full. Therefore, a neon atom is very, very stable. Energy levels, also called electron shells, are fixed distances from the nucleus of an atom where electrons may be found. As you go farther from the nucleus, electrons have higher energy levels. They have more energy. Electrons are always added to the lowest energy level first until it has a maximum number of electrons possible. And then electrons are added to the next highest level until that level is full as well, and so on. The maximum number of electrons at a given energy level depend on its number of orbitals. There are at most 2 electrons per orbital, which means there could be 1 electron in an orbital. Electrons in the outermost energy level of an atom are called valence electrons. They determine many of the properties of an atom, including how reactive it is. So, are you able to see in your mind the idea of energy levels or electron shells? If not, feel free to go back and view this video again. And if you can, then please, by all means, move forward. Have a great day.